So section 3.4, so we're looking at more kinds of equations of lines. So we've seen standard form and we've seen slope-intercept form. So the first objective in this is what we call point-slope form. You could probably guess from its name you need a point and you need the slope. And then we're going to talk a little bit more about equations of vertical and horizontal lines. As well as parallel and perpendicular lines. These are the equations again. So we kind of introduced those in the last section. We're going to work a little bit more with them. And then we're going to do a little bit of problem solving, aka word problems. So let's talk about point-slope form of a line. So this is the third form of a line that we have. It's called point-slope because it requires either 2 points to be able to calculate a slope using slope formula, or 1 point and the slope of the line. And if your slope m is given and you have some point a comma b, then point-slope form, m is the slope, and we have the point a comma b. Then the point-slope form of the line with slope m that goes through the point a comma b is y minus b equals m times x minus a. So this is the form. Now you can simplify this, you can leave it this way. This is point-slope form of the line. So the next couple examples we're just going to work on writing equations in that form. So this first one, slope is -3 and it goes through the point 1, -5. So we have 1 minus a -5 equals -3 times x minus 1. So this is a complete version. You can simplify this and you get -3x plus 3, and then this becomes plus, so we'd be minusing the 5 over. We'd have -2. So you can simplify back to slope-intercept form, but this is point-slope form. The reason we have point-slope form is based on the type of point we're given. So slope-intercept form requires the intercept. That's why it's got it in its name. Point-slope form just requires the slope and any point on the line. So we're a little less restricted than slope-intercept form. Now, because we just need 1 point and we need the slope, if we're given 2 points, we can calculate the slope and then put it into the proper form. So here we're going to calculate a slope, m5 minus 0 over -4 minus 4 is 5 over -8. And so I'm going to use this first point here, 4 comma 0, and this is y minus 0 equals -5/8 times x minus 4. Obviously y minus 0 is just y, and this is -5/8 x plus 5 over 2. So you can simplify it down. You could have left it without distributing the 5/8, but this is the equation of the line. So this is the most open-ended version of the line, because all we need now is 2 points. Any 2 points we want. We can calculate slope and then use one of them to put it into point-slope form. So there's a couple practice problems. Coming back to examples here, we want to write the equation of a line through the point 2, 2 that has undefined slope. So if you remember, undefined slope is when there's no change in x. So delta y over delta x equals some change in y over 0, which means x is always the same, which means that it's a vertical line. And our x is then, since it's got to go through this point, it needs to equal 2. So x equals 2 is our equation of that line. Similarly, if we want to write the equation through the point 2, 2 that has zero slope means that delta y over delta x equals 0 over delta x. This is a horizontal line. And that means if it's going to go through this point, the y never changes. It has to equal 2. Y equals 2. So if you're kind of working through these back to back to back, this may seem easy. If you're taking a break, remember this is just applying the definition of vertical and horizontal lines that we saw in a previous lecture. So there's a couple practice ones here for you to work through. Moving on here, find a parallel and a perpendicular line to 3x plus 4y equals negative 12. And yes, I like this line for whatever reason. So this is using our definitions at the end of the last section of what parallel and perpendicular are. Was that the last section? 2 sections ago, parallel and perpendicular, back in 3.2. So parallel, so the symbol for parallel is 2 straight lines parallel to one another. So this means the slope has to be the same. Now our slope, it's in standard form. Remember, standard form is negative a over b, so negative 3. So this is 3x plus 4y equals negative 12. So it's negative 3 over 4. And the parallel line should go through the point 1, 1. Well, we can use point slope form, so we have y minus 1 equals negative 3 over 4 times x minus 1. So this is a full answer. You can simplify into slope-intercept form, and this would be y equals negative 3/4 x, and it would be plus 7/4, because it'd be negative or positive 3/4 and then plus 1. Both of these are acceptable answers. Now the perpendicular symbol is this symbol. Looks like a, well, it's supposed to look like a 90-degree angle. I can't draw 90 degrees apparently, but it looks like this. Perpendicular, our slope m is negative 3/4 from here, so that means that our perpendicular slope, which you can denote like this, m sub with the subscript of the little perpendicular symbol, has to equal the opposite sign, so positive, and then we flip this number. So instead of 3/4, we have positive 4/3. And our perpendicular line should go through the point negative 3, negative 6. Again, using point slope form, y plus 6, since it's negative 6, y minus negative 6 is plus, equals 4/3, times x minus a negative 3 is x plus 3. Again, this is a complete answer. You have an equation of a line. You can simplify this into slope-intercept form, and you get 4/3 x minus 3. Either of these are acceptable. And so we introduce these. Here's how we find the equations. There's a practice problem for you to try doing the similar problem, parallel and perpendicular, through some given points. Now we're going to work on a word problem here. Southern Star Realty is an established real estate company that has seen growth in sales since 2010. In 2012, the company sold 200 houses, and in 2017, the company sold 275 houses. We're going to predict how many houses this company will sell in 2026. So the first thing is we are looking at sales since 2010. So all of our numbers are after 2010. So 2012 is 2 years after 2010, and they sold 200 houses. 2017 is 7 years after 2010, and they sold 275. Well, we have 2 points. So we can calculate a slope and then use that slope to make a point slope form of a line. So m is 275 minus 200 over 7 minus 2. This is 75 over 5. And 5 goes into 75 exactly 15 times. $15 times? 5 goes into 7 once, 2, bring down 5. Yeah, 15 times. So our slope is 15. We can use either point. I'm going to pick this point here because I like the numbers better. Y minus 200 equals 15 times x minus 2. And I can simplify this if I want to 15x. This would be minus 30 plus 200 is plus 170. Now, just for fun, let's see what happens if we pick the other one. So we have y minus 275 equals 15 times x minus 7. And then simplifying, we have y equals 15x. And 7 times 15 is 105. So this is minus 105 plus 275. And we get y equals 15x plus 170, because 275 minus 105 is 170. So the values that we pick, or the values that we get for the y-intercept, will not change regardless of what point you choose. Just to point that out. And then we're predicting 2026, so we need to, in the little space that I have left, actually, I'll do it down here because this is a practice problem for you. So this is why we need to predict y equals 15. 2026 is 26 years after, or is 16 years, I'm sorry. 16 years after 2010. And so now we're just multiplying this in the calculator. And you should get 240 plus 170 is, 410. Now, again, this is a word problem, so we need context. 410 what? This is 410 houses sold in 2026. That is our context. All right, so another kind of short one here. There's another practice problem very similar to this for you to work on, but that is the end of 3.4.